A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Today we will be talking about durability of concrete. The lecture outlines are durability of concrete, causes of inadequate durability. We will talk about the different causes of inadequate durability or which are affecting the durability of the concrete. Then we will be talking about the hot weather concreting and cold weather concreting. We will try to cover some of the topics in today's lectures and the rest of the topics in the coming lecture. So let's talk about durability of the concrete. That what is durability? Durability of concrete can be defined as the ability of the concrete to resist the weathering action, the severe weathering action, that is having the chemical attack and abrasion, while maintaining its desired engineering properties. So durability of the concrete can be easily defined as the ability of the concrete of the concrete so that it can resist the weathering action, that is the freeze and thaw action, also can resist the chemical attacks, that is the sulfate attack and the chloride attacks, and can also resist the abrasion, that is the wear and tear of the concrete if some surfaces are coming in contact with this concrete. And it will have to maintain its desired engineering properties. So what are the desired engineering properties, Dawood Khan? What are the desired engineering properties of concrete?
सर जिसके लिए हमने कंक्रीट को डिजाइन किया होता है कि मतलब ये कितना लोड बर्दाश्त करेगा,
For
कितना
example, for example,
कि इसका कंप्रेसिव स्ट्रेंथ कितनी होगी सर, मतलब
good,
ये कितना लोड, फ्लेक्सर
yeah,
स्ट्रेंथ, ये
how much
टेंसाइल
should be
वगैरह इस तरह.
strength, hardness, toughness, and all other properties. These are called the desired properties, yeah, which a civil
यस सर.
engineering or material engineer is interested in these properties. So durability is the ability to last a long time. As it is clear from the name, durability is the ability of the concrete so that it can work for a long time without requiring maintenance and repair work and without having significant deterioration. A durable material helps the environment by conserving resources and reducing waste and the environmental impacts of repair and replacement. It is very interesting statement that a durable material, that material which you have used in your construction or in your project or in your house, if that material is durable, how it will help the environment? It will help the environment. How? Uh, Let me ask someone. Muhammad Ahmad.
जी सर.
Muhammad Ahmad. Beta, can you comment on this statement? How it will be helping the environment? It is written.
सर
जी बेटा.
एनवायरनमेंट के लिए
Uh-huh.
सर हमारे पास रिसोर्सेज कंजर्व करता है और जो वेस्ट हमारे साथ प्रोड्यूस होता है तो उसमें कमी आती है.
Uh-huh. Okay. Amara Amir. Beta, can you comment on this? Muhammad Ahmad has already explained this. Can you add some more comment?
Yes, sir.
Ji beta. We are saying that a durable material, if we use durable material, it will help our environment. How it will be helping? By conserving the resources and reducing the waste and the environmental impacts of the repair and replacement. इसका क्या मतलब है?
सर यही कि अगर हम लोग ड्यूरेबल मटेरियल यूज करेंगे तो हम लोगों के पास एनवायरनमेंट जो है वो कंजर्व
बेटा
रहेगी.
ऊंचा बोले बेटा. जी बेटा.
सर यही कहा हुआ कि ड्यूरेबल अगर मटेरियल यूज करेंगे तो उससे जो है वो एनवायरनमेंट कंजर्व रहेगी.
देखिए बेटा, it is written over here. It will conserve. It will save the resources. It will save the resources for the coming generation. And it will also reduce the waste which are generating when we are producing more material, and it will save, it will not affect the environment, it will cause no impacts on the environment when you are needing more material for repair and replacement. If you are not using durable material, what will happen or what will be the consequences? That there will be cracks or there will be deterioration in the concrete or in the structure. So you will need to repair that deterioration or that cracks. For that, you need extra material. Or if this cause disintegration or collapse or major cracks in the concrete, so then you have to go to replace the whole structure or some components of the structure. So for that, you will need more material. So if you need more material, then you are utilizing the resources. You are not conserving the resources, but you are using the resources. You are not saving the resources for coming generation, but you are utilizing the resources to repair your structure and to replace your structure. So it is better to use durable materials so that you can save the resources for coming generation, and also you can reduce the waste and the environmental impact. The production of additional building materials. The production of additional building materials required for this repair and replacement reduces the natural resources, as we discussed, because you will be utilizing the natural resources of coarse aggregate and fine aggregates, and also the resources which are utilized in making this cement, and can produce air and water pollution. So when you are producing these waste, when you are producing these materials, or when you are extracting this material from the rocks or from their quarries, then it will cause air and water pollution. So with the help of using durable material, you can mitigate the air and water pollution as well. Durable concrete resists weathering action. If you have used the durable concrete, it will be strong enough so that it can resist the weathering action. That is the freeze and thaw action. The chemical attacks, it will be able to resist the sulfate and other chemical attacks, and the abrasion, that is the wear and tear, while maintaining its desired engineering properties. That is, it will be having high strength, high durability, high toughness, and high hardness. It normally refers to the duration or lifespan of trouble-free performance. You can refer this durability as the duration or the time or the lifespan or the design period of the structure which it can work or it can perform its services without having any trouble or any damages or any crack. Different concretes require different degrees of durability. As we have discussed already, it depends upon the type of the project. If you have a high level project, just like you are making nuclear power plants or hospitals, which have national importance as compared to your own house, then you will need high durable concrete as compared to the one which you are using in your own house, depending upon the exposure environment. Now, this concrete or the properties of this concrete depends upon the exposure environment, that to which environment it has been exposed, and the properties desired, and what are the required properties, how much is the strength, how much is the toughness, how much is the hardness. For example, concrete exposed to tidal seawater, when it is coming, when the concrete is coming in contact with seawater which have chlorides, will have different requirements than an indoor concrete floor. So if you have used indoor concrete, it will have different requirements because it will be on more safer side. But if you have used concrete on seaside or on ports, then what will happen when this seawater is coming in contact with this concrete, it will try to go inside the concrete, and if you have used steel bars in the concrete, it will cause corrosion of this reinforcement, and once corrosion of this reinforcement is causing, it will cause debonding of the concrete and steel bars, so it will affect the overall structure of the concrete. Concrete ingredients, that is the fine and coarse aggregate, water cement ratio, they are proportioning how much you are using this in proportions, the interaction between these particles and cement paste, placing and curing practices, how much, which type, how you have placed this, how you have handled this on site, and which method of curing you have used. You have simple used the spray, or you have used the steam curing, or some other special method for curing, and the service environment, or in the environment in which it is giving services, determine the ultimate durability and the life of the concrete. So if you don't have severe weather conditions on site, then you are not supposed to need high durable concrete. But you have severe weather conditions, you have this sulfate and chemical attacks on site, you have abrasion, the probability of abrasion of this concrete, there are the chances of some surfaces or some tiles or some other materials which have the probability to come in contact with the surface of the concrete. Then for that you will need high durability of the concrete. Now, what are the causes of inadequate durability? How the durability of the concrete is affected? So the concrete durability is affected by two causes. One is the physical cause and the other is the chemical cause. In the physical causes, we have permeability, we have the freeze and tie action or alternate freezing and tying of the concrete, which can affect the durability of the concrete. We have the abrasion or erosion of the concrete, which can affect the durability of the concrete. And in the chemical causes, we have alkali silica reaction, we have sulfate attack, which can affect the durability of the concrete, and we have chloride action and reinforcement corrosion, which affect the durability of the concrete. Ahmad Tariq, can you hear me? Ahmad Tariq. Ahmad Tariq. Okay, Jalal Bashir. Jalal Bashir. Jalal beta.
जी सर.
Can you hear me?
Yes sir.
जरा माइक के करीब हो जाए बेटा, ऊंचा बोले, आपकी आवाज नहीं आ रही है.
जी सर.
Beta, can you comment on the permeability of concrete, how it will cause or how it will affect the durability of the concrete?
The more permeable the concrete, the more water.
जी बेटा. Do you know permeability?
Yes sir. The absorption rate.
Muhammad Umair. Muhammad Umair. Muhammad Umair. Hezbollah, class number 1. Hezbollah. Hezbollah. Hezbollah, you have not commented in the class. This is almost, we are in lecture number 11 or 12, but you have not commented, you have not answered even a single question. Class number 1, Hezbollah. Okay, Bakhtar Shah.
जी सर.
Bakhtar Shah. Beta,
जी सर.
what is permeability and how it causes or how it affects the durability of the concrete?
Sir, permeability mean to permit something or to pass something from a material. So ये इस तरह permeability सर इफेक्ट क्वेश्चन दोबारा पूछो सर. permeability का सर किस चीज पे? ड्यूरेबिलिटी पे.
या ड्यूरेबिलिटी को किस तरह अफेक्ट करती है?
अच्छा, तो permeability मतलब बात चीज इस तरह होती है जो कि मुख्तलिफ किस्म की चीज जो चीज को खराब कर देती है उसको अलाव कर देती है और बात चीजें इसको अलाव नहीं कर देती. तो permeability जितना ज्यादा होगा मतलब.
So please talk to the point. Talk in terms of concrete.
Okay sir. तो सर जितने परमेबिलिटी ज़्यादा होगी कंक्रीट में मुख्तलिफ चीज़ों की उतने उसकी ड्यूरेबिलिटी कम होगी सर. एंड वाइस वर्सा.
What is permeability? What is permeability of the concrete? And how it will affect the durability?
सर मुख्तलिफ चीज़ों का पास होना कंक्रीट. ओके
ठीक है बख्तर शाह, ठीक है, अपना माइक बंद कर दें. उसामा.
ओके सर.
Usama bin Azhar. Awais Rahman. Awais Rahman, are you in the class? Okay, Junaid Shah. Junaid Shah, can you hear me?
Yes sir.
Okay beta, go ahead. Can you comment on this?
जी हाँ सर, सुन रहा हूँ आपको.
जी बेटा.
ये सर परमिएबिलिटी कंक्रीट में जब वाटर पास होते हैं कंक्रीट अगर वाटर को
Shabash.
एलो करते तो वो कंक्रीट परमिएबल होगी।
Good, shabash. And how it will affect the durability of the concrete?
सर इसका जो रिलेशन है कंक्रीट के साथ वो इन्वर्सली प्रोपोर्शन है। अगर परमिएबिलिटी ज़्यादा होगी तो ड्यूरेबल कम होगा, डैम्पिंग होगी उसमें।
Okay, good, shabash. Okay, let's go to Dawood Khan again. Dawood Khan,
Yes, sir.
please tell them how it will affect the durability.
सर अगर परमेबिलिटी होगी तो ये जब वाटर और आयंस वगैरह को अंदर परमिट करेगा तो क्लोराइड
Good,
आयंस से
shabash.
जो बार्स होंगे हमारे पास उसमें कोरोजन होगी और इसी तरह दूसरे जो आयंस
Exactly,
होंगे तो
shabash.
अटैक्स आसानी से होंगे। और दूसरी बात है कि परमेबिलिटी ज़्यादा होगी तो इट मींस कि इसमें वर्ड्स ज़्यादा है और वर्ड्स का स्ट्रेंथ के साथ भी इनवर्स रिलेशन है।
Exactly, good, shabash. Well done. Class number 6. Let me give you 0.5 sessional marks. Okay, so let's talk about the permeability. Permeability can be defined as the property that governs the rate of flow of a fluid into a porous solid. Or permeability can be also defined as the ability of a material to allow the water to pass through it. So, permeability of concrete is the ability of concrete to allow the water to pass through this concrete. Concrete durability gets affected when there is a chance of penetrability of water into it. When the water have the chances or the probability that it can go inside the concrete, then its durability will be affected. Permeability of water into concrete expand its volume. What will happen if the water goes inside the concrete? It will increase the volume of the concrete and it will cause formation of cracks in the concrete. And finally, it will cause disintegration of the concrete. Generally, concrete contains small gill pores and capillary cavities. There are two types of pores or voids in the concrete. One are called gill pores and other is capillary cavities. However, gill pores do not allow penetration of water because it have very small size. So the gill of the concrete, it will not allow the water to pass through it. But the capillary cavities on the other side, the capillary cavities in concrete are responsible for permeability, which are formed due to high water cement ratio. If you remember in the bleeding of the concrete, when this water comes to the surface of the concrete, they are making paths in the concrete, and these paths are remains open for a long time or during the lifetime of the concrete. So when there is rainwater is coming or some other water is coming in contact with the concrete, it will go to these paths inside the concrete. To prevent permeability of the concrete, to make it more impermeable, what you can do? Lowest possible water cement ratio must be recommended. You should use lowest water cement ratio. The next, what you can do, how you can mitigate the permeability of the concrete? You can use pozzolanic materials, which helps to reduce the permeability by filling the capillary cavities of the concrete. So let me ask someone, Sophia Server, beta, can you hear me? Sophia Server.
Yes, sir.
Beta, can you define pozzolanic material? What is
Sir,
pozzolanic
pozzolanic
material?
material. Yes, sir. Pozzolanic material are those that have cementitious property when they are mixed with water.
Okay, so how it can prevent the permeability of the concrete if we use pozzolanic material in the concrete?
Sir, so it will absorb the extra water in the concrete. So जब ये extra water absorb,
because these materials have very small size, so it will fill the capillary cavities. It will fill the
yes,
capillary cavities, and there will be less chances of water to flow inside the concrete. Here you can see the permeability is water which is coming in contact with the concrete surface, and when it go inside the concrete, so it will try to reach to these steel bars. When it reach to the surface of these steel bars, what will happen? Corrosion of this reinforcement will be causing. And due to corrosion of these steel bars, what will happen? The debonding of this concrete with the steel bars will occur, and due to the debonding, the separation or the spalling of the concrete will take place. The next cause of inadequate durability is is the freeze and thaw action of the concrete. So let me ask someone. We have already discussed this freeze and thaw action, or the freezing and thawing of concrete. So Amir Hamza beta,
जी सर.
can you comment on this freeze and thaw action, how it will affect the durability of the concrete?
यस सर, इस पर तो हम बहुत बात कर चुके हैं. फ्रीज एंड थॉ में सर, जब पानी जब हम कंक्रीट करते हैं सीवियर कंडीशन में, यानी कि टेम्परेचर लो होता है, तभी सर जो वाटर होता है उसका वॉल्यूम कम हो जाता है. कम टेम्परेचर पे, यानी 4 डिग्री से कम पर उसका एनोमलस बिहेवियर शो हो जाता है. उसकी वजह से वो वाटर एक्सपैंड हो जाता है, वॉल्यूम उसको, उसमें कंक्रीट में क्रैक्स पैदा हो जाते हैं उसकी वजह से, और ये ड्यूरेबिलिटी को इफेक्ट करता है.
Okay, good. So how we can prevent it? What are the precautions, or how we can mitigate it, or how we can stop it?
हम सर एडमिक्सर यूज़ करते थे सर, वो एयर इंटरनिंग एडमिक्सर, जब वो यूज़ करते हैं सर तो उसमें एयर बबल्स प्रोड्यूस हो जाते हैं बहुत छोटे छोटे से. तो उसमें जब वाटर एक्सपेंड होता है तो उसी वॉइड्स में एक्सपेंड हो जाता है और कंक्रीट को इफेक्ट नहीं करता.
Good, well done. Amir Hamza, what is your class number?
40.
40. I have given you 0.5 sessional marks.
थैंक यू सर.
Okay, so let's discuss this freezing and thawing of the concrete. So deterioration of concrete, or cracking of the concrete, or damaging of the concrete from freeze and thaw actions may occur when the concrete is critically saturated, when it has high water content, which is when approximately 91% of its pores are filled with water. 91% of its pores are filled with water. When this water, or when the water freezes to ice, it occupies 9% more volume than that of the water. So what will happen for this extra volume? If there is no space for this volume expansion in a porous water containing material like concrete, freezing may cause distress in the concrete, or can cause cracking of the concrete, because this extra volume of the ice, it will exert pressure, it will exert stresses on the concrete, and due to these stresses there will be chances of cracking of the concrete. These stress to critically saturated concrete from freeze and thaw action, or from freezing and thawing, will commence with the first freeze-thaw cycle. So when the first freeze-thaw cycle will get start, these stresses or exerting of pressure on the concrete will start, and this will continue throughout successive winter season, because in the winter season this freeze and thaw action will be continuing. So in this whole season, this process will be continued and will be repeated, and will be resulting the loss of concrete surface, or the cracking of the surface, or the cracking of the concrete wherever this freeze and thaw action will take place, and where these forces will get the weak area, or the weak zone inside the concrete. To protect concrete from freeze and thaw damage, it should be air entrained. When it has a proper system of microscopic air bubbles, which we have produced with the help of air entraining admixtures, obtained through the addition of an air entraining admixtures and thorough mixing, concrete is highly resistant to freeze and thaw action. When we can use the air entraining admixtures, and we can properly distribute these microscopic air bubbles throughout the volume of the concrete, then we can make it resistant to this freeze and thaw action. These microscopic air bubbles within the concrete accommodate the expansion of water into ice, and thus relieve the internal pressure generated. So we can mitigate this freeze and thaw action, or the damages due to this freeze and thaw action in the concrete, and we can make the concrete more durable. Concrete with a low water cementitious ratio, as we discussed, 0.4 or lower, is more durable than concrete with a high water cementitious ratio, that is 0.5 or higher. Air entrained concrete with a low water cementitious ratio and an air content of 5 to 8% of properly distributed air wires throughout the concrete will withstand, or will resist, a great number of cycles of freezing and thawing without making cracks, or without exerting pressures or stresses on the concrete. Here you can see, maybe already you people have seen such cracks on in the concrete or in the roads or in the buildings. Here you can see the snow, and here you can see the spalling of the concrete. So when this freeze and thaw action will take place, it will cause damages of the concrete, or it will cause cracking of the concrete. So the surface concrete has already been damaged, and it has already gone separated from the other part of the concrete. And you can see these steel bars are now exposed, and it has already been corroded. The next topic is abrasion, how it causes inadequate durability. So let me ask someone in the class so that he or she can get sessional marks. Hushyamul Hassan. Hushyamul Hassan. Hushyamul Hassan, are you in the class? Diljan Khan. Diljan Khan, can you hear me? Awais Rahman. Awais Rahman, I hope your internet is working now. Awais Rahman from Warsak Road. Beta, can you hear me? Are you in the class? Okay, no response. Durri Kamla Sadiqi.
Yes, sir.
Beta, can you define abrasion? We have already talked about this in the first semester in the material course.
एब्रेशन वेयर एंड टेयर फोर्सेस से प्रोड्यूस हो जाती है, इसको एब्रेशन कहते हैं.
The wear and tear of concrete is known as
एब्रेशन.
abrasion. What is your class number?
2 सॉरी 2 है
28.
2 है.
Class number 2.
Yes.
02. Okay. So 0.5 sessional marks. This was a very simple question. But Awais Rahman and all other guys, Hushyamul Hassan, they have missed it. Okay. Hezbollah. Are you in the class? Class number 1. Hezbollah. हिजबुल्लाह, आप मैसेज करते हैं लेकिन आवाज आपकी नहीं आती है. Hezbollah, you are not supposed to upload your assignment before the due time. Also, you uploaded your midterm paper before the due time, and then most of the students they were asking for access to your paper. I hope you have not shared your paper with the students. Okay, so let's talk about the abrasion. Deterioration of concrete also occurs due to severe abrasion. So abrasion is the wear and tear of the concrete when some surfaces or some materials are coming in contact with this surface and moving on this surface. When concrete is subjected to particles in rapidly moving water, when water is continuously passing or coming in contact with these surfaces, or steel tires are passing on these surfaces, you have installed some machinery on the surface or on the top of the concrete, or floating ice. You have some ice factory and the ice is continuously passing through these surfaces. So the wearing of surfaces occurs and durability is affected. You can see it has already been damaged. The top surface has been removed due to the wear and tear of other materials or other surfaces. Higher the compression strength, higher will be the abrasion resistance. If you have high strength of the concrete, it will be more resistance to this abrasion. And if you have lower strength of the concrete, it will be less resistance to abrasion. Now let's talk about the chemical causes of inadequate durability. So let's talk about the alkali silica reaction. So alkali silica reaction, ASR, is an expansive reaction between certain forms of silica in aggregates and potassium and sodium alkali in the cement paste. So when you have active silica content in the aggregates, that is normally in the coarse aggregate, so when you have this active silica, what will happen, this active silica will react with the potassium or sodium alkalis in the cement paste, and this will cause swelling of the concrete or expansion of the concrete. The reactivity is potentially harmful only when it produces significant expansion, significant swelling of the concrete. Indications of the presence of alkali aggregate reactivity may be a network of cracks. You will see a network of cracks on the surfaces of the concrete. Closed or spalling joints. You will see when there are joints in the concrete, then at these joints you will see some cracks on the surfaces. If you have this joint on this side or on this side of the concrete up to 2 feet, you will see a network of cracks or spalling of concrete or movement of portions of a structure. So all these are the causes of inadequate durability. You will see this in the pictures, how this causes the cracks in the concrete. This reaction causes the expansion of the altered aggregate by the formation of a swelling gel of calcium silicate hydrate. These, after the reaction of these active silica in the aggregates with the alkalis in the cements, they are making calcium silicate hydrate gel. And with the passage of time, when they are getting water, this gel is going to increase in volume. Its volume increases, and it causes swelling of the concrete. This gel increases in volume with water and exerts an expansive pressure on the concrete or inside the material, and this causing spalling or removal of the concrete and loss of strength of the concrete, finally leading to its failure. So here you will see, you can see these are network of cracks. Here you can see network of cracks. These are the cracks due to this alkali silica reactivity. So use of how we can mitigate this reaction, how we can mitigate this cause of inadequate durability. Use of cement with less alkali content. We should use such cements in which there are no high content of alkali, so that it cannot react with the silica content or the active silica content of the aggregates. Non-reactive aggregates, you people should use such aggregates. You people should test the aggregates before using it in the concrete, and if it have high or reactive silica or active silica content, then you are not supposed to use this in the concrete. You should use pozzolanic materials like fly ash or slag cement. Slag cement, anyone in the class who can explain the slag cement? Ji, Awais Rahman. जी बेटा मोहम्मद उमेर मोहम्मद अब्बास खान सादुल्ला सहराई सलमान खान उमर हयात बेटा, are you in the class? Wajahat beta?
Yes, sir. Sir.
Are you in the class? You can hear me?
Yes, sir. Yes, sir. I can hear you, sir.
Okay, beta. Good. So,
sir, slag cement is a hydraulic cement in which. Yes, sir. Yes, sir. Sir, slag cement is a hydraulic cement in which ground blasted furnace slag is grounded to a suitable fineness and is used to replace the portion of a cement.
And it is the byproduct of what?
Sir, it is the byproduct of sir, blast furnace slag is used to replace the suitable part of Portland cement, and the cement which is formed
is the byproduct of iron blast furnace.
Yes, sir.
You can use lithium-based admixtures as well to stop this disability in the concrete.
Yes, sir.
Okay, अपना mic बंद कर दे बेटा, शाबाश.
Yes, sir. Thank you.
The next cause of inadequate durability is the sulfate attack. So, excessive amount of sulfates in soil or water can attack and destroy a concrete that is not properly designed. If you have not used the sulfate resisting cements, you have not properly designed the cement which can resist the sulfate attack, then the sulfate present in the soil where you are making your structure, or the sulfate present in the groundwater or the water surrounding your structure. Maybe you have a canal, or you have seawater or some other sources of sulfates in the water. So what will happen? It will cause inadequate durability, or it will affect the durability of the concrete. Sulfates, for example, calcium sulfate, sodium sulfate, and magnesium sulfate. This can attack on the concrete by reacting with the hydrated compounds in the hardened cement paste. These sulfates, it will react with the hydrated compounds of the cement, and this will cause swelling of the concrete, or it will cause increasing the strength of the volume of the concrete. These reactions can induce sufficient pressure to cause disintegration or cause cracks of inside the concrete or on the concrete. Like natural rocks such as limestone, porous concrete, generally with a high water cementitious ratio, as we discussed, this water cement ratio is the most important phenomenon or most important thing in making the concrete. It's susceptible to weathering caused by salt crystallization. So, example of salt known to cause weathering of concrete include sodium carbonate and sodium sulfate. So we should try to keep the water cement ratio as minimum as possible. And sulfate attack and salt crystallization are more severe at locations where the concrete is exposed to wetting and drying cycle than continuously wet cycle. If you have this freeze and thaw action or wetting and drying of the concrete in such places, then it is more severe. It will get more cracks, or it will be more affected, and its durability will be more affected. It will be less durable when it is exposed to wetting and drying. It becomes wet, and after some times it becomes dry. So when they are exposed to such cycles, it will be more affected than when it is completely wet. There are no chances of drying. You can see the spalling due to sulfate attack. You can see the spalling of the concrete, and here you can see the spalling of the concrete. So here you can see the cover of the concrete which we provided to cover these steel bars, to cover them from the chlorides and other severe weather conditions, so that to keep them away or to keep them safe from corrosion. So these are the causes of these sulfate attacks, that the swelling of the concrete have been taken place, and the debonding of the concrete and steel bars have been taken place, and now these steel bars are exposed to corrosion, and already they have been corroded. For the best defense against external sulfate attack, design a concrete with a low water to cementitious material ratio and using sulfate resisting cement. This is the best solution. Or you can use slag cement, and you can decrease the permeability of the concrete. If you can make the concrete surface impermeable, it will not allow the water to go inside this concrete. So when they are not going inside this concrete, this sulfate will not attack on the concrete. There will be less chances of the sulfate attack on the concrete. So we can save our concrete from sulfate attack. The next one is the seawater exposure. So let me ask someone in the class, Amir Hamza beta. Amir Hamza.
जी sir.
Can you comment on this? When our concrete is exposed to the seawater, what will happen? We have already discussed in our previous slides. And if it is not exposed to the seawater, then how will be its performance or its services?
सर सी वाटर में साल्ट बहुत ज़्यादा होता है. जब वो कंक्रीट उसको एक्सपोज हो जाता है तो एक तो उसमें कंक्रीट में वाटर एब्जॉर्ब हो जाता है, दूसरा उसमें नमक भी एब्जॉर्ब हो जाता है. उस पर साल्ट की वजह से क्रिस्टलाइजेशन होती है और 3D शेप बना लेते हैं, जिसका वॉल्यूम एक्सपेंड हो जाते हैं और फिर कंक्रीट पर प्रेशर एक्सर्ट करते हैं और उसमें क्रैक्स प्रोड्यूस करते हैं.
Good, shabash, well done. Seawater exposure. Concrete has been used in severe exposure for decades with excellent performance. Concrete has already been used to seawater exposure. There has been used, or concrete has been used on ports and harbors, and they have excellent performance. However, special care in mix design and material selection is necessary for these severe environments. A structure exposed to seawater or seawater spray, when it is in contact with seawater, there are chances that the seawater will be spraying on this concrete when these tidal waves are coming, or is more, then this concrete becomes most vulnerable in the tidal or splash zone when this water is spraying on this concrete, where there are repeated cycles of wetting and drying, as I explained in the previous slides, and there are the chances of freezing and tying in the concrete. Then the probability or the chances of this concrete to become vulnerable are increasing. Sulfates and chlorides in seawater require the use of low permeability concrete to minimize steel corrosion and sulfate attack. So the most important thing, that is the physical property, that was the permeability. We have to make the concrete impermeable to use the lowest possible or optimum water cement ratio to have less or minimum or zero pores or voids in the concrete. A cement resistance to sulfate exposure is helpful. If you can use the sulfate resisting cement, then it will resist the seawater effect on the concrete. Proper concrete cover over reinforcing steel must be provided, and the water cement ratio should not exceed 0.4. So if you remember, I told you this is the cover on the concrete. You can see this concrete. So if you can provide a proper cover on the concrete, so this cover will protect the steel bars, and there will be no chances of corrosion of these steel bars. The next property which causes inadequate durability is the chloride ingress and steel corrosion. So chloride present in plain concrete that does not contain steel is generally not a durability concern. Okay, let me ask someone. Jalal Bashir.
Yes, sir.
Jalal?
Yes, sir.
Jalal, can you hear me?
Yes, sir.
जलाल बेटा आपकी आवाज नहीं आ रही. मोहम्मद उमेर. When I am asking question, then most of the students leave the class. So please do not leave the class. It has nothing. You can say sorry, sir. If you don't know the answer, you can say sorry. Okay, Salman Khan. Salman Khan. Umar Shehzad. Umar Shehzad. Umar Hayat. Okay, so mic is not working for some students. Okay, Dawood Khan, beta, please explain this plain concrete to the students.
सर प्लेन कंक्रीट वो होता है जिसमें हम स्टील यूज नहीं करते, रिबार्स यूज नहीं होते सर.
Yeah, plain concrete, as it is clear from its name, that plain concrete is that concrete in which there is no reinforcement. There are no steel bars in the concrete. So when there are no steel bars in the concrete, there will be no chances of the erosion or the corrosion of the concrete. So it will not affect the durability of the concrete. Chloride present in plain concrete that does not contain steel is generally not a durability concern. It will not affect the durability of the concrete. Concrete protects embedded steel from corrosion through its highly alkaline nature. Due to the highly alkaline nature, it has pH value greater than 12.5. It is protecting the steel embedded or the steel used inside the concrete from corrosion. The high pH environment in concrete, that is 12.5, causes a PSU, that is non-reactive and non-corroding protective oxide film to form on steel. It is making a non-corroding protective film on the top of the steel bars, and they are protecting the steel bar from the corrosion. The resistance of concrete to okay, let me explain this. There are two types of concrete. One is the plain concrete, the other is called reinforced concrete. So in plain concrete, we are using only concrete, and in reinforced concrete, we are having the steel bars as well inside the concrete. So when you are having reinforced concrete, then there are the chances, if you have this chloride present in the concrete, then this will attack on the steel bars and will cause corrosion of the of the reinforcement. As you have seen over here, this steel has been corroded. So the resistance of concrete to chloride is good. However, for severe environments such as bridge decks, that is the top surface of the bridge, it can be increased by using a low water cementitious ratio. What can be increased? The resistance can be increased. If you are using the water cement ratio up to 0.4 or less than that, at least you are providing 7 days moist curing to the concrete. And supplement, you have used supplementary cementitious material such as silica fume or some other supplementary cementitious material to reduce the permeability of the concrete. So how you can protect the concrete from chloride ingress? Number one, you can keep the water cement ratio as low as possible, less than 0.4. You have to keep the concrete moist for at least 7 days. You have to use the supplementary cementitious material, that is the pozzolanic material like silica fume, and you have to use, or you have to reduce the permeability. You have to make the concrete impermeable to fill all the voids in the concrete properly. Increasing the concrete cover, as I explained in the previous slide in the picture, if you can increase the concrete cover, the thickness of the concrete cover, the steel also helps slow down the migration of chlorides. If you can increase this cover of the concrete, if you can increase the thickness of the concrete, it will slow down the migration or the transfer of the chloride towards this steel bars, and it will protect, or it will minimize, or it will slow down the corrosion of the reinforcement. Other methods of reducing the steel corrosion include the use of corrosion inhibiting admixtures. You can use such admixtures which can help in resisting the corrosion of the reinforcement. And such admixtures make the steel bars spacio, that is non-reactive for corrosion. It increases the durability of the concrete, and such type of admixtures are like calcium nitride and sodium nitride. You can use epoxy coated reinforcement. You can use already treated reinforcement bars, the surfaces of which have already been treated, which can resist the corrosion. You can use the surface treatments. You can provide paints on the steel bars, and you can provide the concrete overlays on the top of the steel bars or on the top of the concrete surface, so that to avoid the corrosion of these steel bars. Coming towards the last topic of today's lecture, that is the delay ettringite formation. So in the sulfate attack, this phenomena is taking place. So what is ettringite? Ettringite is a hydrous calcium aluminum sulfate mineral having this formula. This is the chemical formula of this ettringite. How ettringite is taking place? So ettringite is primarily the product of the hydration reaction. It is coming from the hydration reaction between tricalcium aluminate and the sitting retarder, that is the gypsum. Okay, so they are making these crystals. These are ettringite, these crystals, and these crystals are increasing in volume with the passage of time. Its volume increases, and it causes swelling of the concrete. It causes cracking of the concrete. So delay ettringite formation occurs if the ettringite, which normally forms during hydration, is decomposed. How this delay ettringite formation is taking place? When these crystals, which have already been formed, it decomposes, and again subsequently reforms or dobara ban jate hain in the hardened concrete. Damage to the concrete occurs when the ettringite crystals exert an expansive force within the concrete as they grow. As I told you, when these crystals are growing, its volume increases, its size increases, it will exert pressure on the concrete, it will exert stresses on the concrete, and due to these stresses or due to this swelling, it will cause cracks in the concrete, it will damage the concrete. In normal concrete, the total amount of ettringite which forms is evidently limited by the sulfate contributed by the cement initially. How it can be limited? It can be limited by the sulfate contribution. It follows that the quantity of ettringite which forms is relatively small. Ettringite crystals form widely dispersed throughout the cement paste on the concrete. If expansion causes cracking, if expansion of these crystals causing cracking in the concrete, this ettringite may subsequently form in these cracks. but this does not mean that the entringite in the cracks caused the cracks initially. It is not necessary that these cracks has been formed by this entringite. It can be caused by some other factors as well. Delayed entringite formation usually occurs in concrete which has either been steam covered. As I told you, when you have provided steam covering to the concrete, then it will be affected by the entringite formation, or which reach to a high temperature during the curing period as a result of the exothermic reaction of cement hydration, or if you have provided external heat to the concrete. As the curing temperature of the concrete increases, entringite normally persists up to about 70 degrees C. It can stay, or it can resist temperature up to 70 degrees C. But above this temperature, if the temperature goes above 70 degrees C, it will decompose. In mature concrete, monosulfate is usually the main sulfate containing hydrate phase, and this persists up to about 100 degrees C. Delayed entringite formation could occur in concrete which was heated externally. As I told you, you have provided external heating from fire, or you have provided steam covering to the concrete, then this delayed entringite formation can take place in this concrete. As mentioned over here in this molecule, or in this chemical name, or in this chemical formula, you can see such high quantity of water in this formula. So normally this entringite formation is taking place when in the wet condition, when there is water, or when the concrete is wet. But when the concrete is dry, then this formation cannot take place. Okay, we will discuss these de-icing effects in our next class, in the remaining hard weather and cold weather concreting. So if when you go back to the books, or to your houses, or to the hostels, please read all these topics carefully. There will be a quiz in the next class, and this quiz will be in the whole course which we have covered after the midterm exam. There will be MCQ just like the previous quiz, and I hope you have got what I have tried to explain in today's lecture. If you have any question, you can ask. Any question, beta? Okay, if there is no class, if you have any question, you can email me, or you can send me a message. Okay, there is one question. Mature concrete, the concrete which has become harder, which has become mature, just like you people are saying this guy is mature one. This guy has very matured approach, sound approach, proper approach. So mature concrete is that concrete which has got sufficient strength, sufficient toughness, sufficient durability, sufficient hardness, is called mature concrete. Is there any other question? Okay, so let me stop the recording. Group number 1 students are requested to stay in the class, and all other students are requested to please leave the class.